Students, hi, I am Pardeep Koul, lecturer in chemistry, and today's topic for you is points of difference between ideal gases and real gases. We have already studied about ideal gases and real gases also. Let me throw a bit of light on ideal and real gases first, then we will discuss the points of difference between these two gases. Now, as far as our ideal gases are concerned, ideal gases are those which obey gas laws, or in other words, which obey this equation. Which equation this is? This is ideal gas equation. So all those gases which obey this equation, that is PV is equal to nRT, such gases are referred to as ideal gases. But as you know that we do not have these gases because such a situation cannot be reached at. Such a situation can be reached only under two conditions. One, that is very high temperature, and very low pressure. These are the two conditions at which we can have ideal gases. But as I told you that such a condition, such a situation is never reached at, and that is why we do not have these ideal gases. So the concept of ideal gases is hypothetical. It is imaginary. We do not have ideal gases. So there are some other differences between our ideal and real gases. So today we will discuss the points of difference between the ideal gases and the real gases. First point is that our ideal gas, an ideal gas obeys gas laws, that is Boyle's law, Charles' law, then we have Avogadro's law, then Gay-Lussac's law. So those gases which obey those gas laws, an ideal gas obeys gas laws under all conditions of temperature and pressure. There should be no bar of temperature and pressure. Under all conditions of temperature and pressure. So, what are ideal gases? Ideal gases are those which obey gas laws under all conditions of temperature and pressure. While as our real gases, they do not obey this law, and if they obey this law, only under two conditions. Those two conditions are they can obey this law. A real gas obeys gas laws, but under some conditions. Under very high temperature and very low pressure. When such a condition is provided, such a situation is provided, then our real gases obey the gas laws. So what happens at very high temperature? When we provide very high temperature to a gas, the gas molecules they expand the intermolecular distances, they begin to increase, and the interactive forces they weaken, and such gases are known as real gases. So this is one difference between ideal gas and the real gas. Then another is volume of a molecule of gas. In case of ideal gases, volume of molecule of gas is negligible. That means it is so small that we can neglect it. Negligible as compared to total volume of the gas. As compared to total volume of the gas. So, in case of ideal gases, the volume of a molecule, of one molecule of a gas, is so small that it is negligible as compared to the total volume of the gas. But as far as our real gases are concerned, this is quite reverse of it. The volume of molecule of a real gas cannot be neglected. This is also one of the causes of deviation of ideal gases from their ideal behavior, of the gases from their ideal behavior. So volume of molecules of real gases cannot be neglected. That means they do have some volume, while as here in case of ideal gases, the volume of a molecule of a gas is so small, it is considered so low that we neglect it. So this is one another difference between the ideal gas and the real gas. Then coming to attractive forces. Attractive forces between the molecules of these ideal gases, they are neglected. The attractive forces between ideal gas molecules are neglected or at all ranges of temperature and pressure. The attractive forces between molecules of gases. Which gases this time? These are ideal gases. The attractive forces between molecules of gases are neglected. Why they are neglected? Because those forces are very weak forces. Neglected at all temperature and pressure. At all ranges of temperature and pressure, the attractive forces between the molecules of ideal gases, they are neglected. Why they are neglected? Because they are considered as very weak forces. That is why we neglect those forces. While as in case of real gases, these forces, that is the attractive forces, cannot be neglected. Attractive forces cannot be neglected at high pressure and low temperature. Why? Because suppose I have container here, we have a gas in it. This is the piston. Now suppose we bring down the piston. By bringing down the piston, what will happen to the pressure? The pressure will increase. So this piston, this is a movable piston. Suppose this reaches here. What will happen to the pressure? Pressure on the gas will increase. So when pressure increases, what will happen to the attractive forces? They cannot be neglected. That means there will be some attraction between the molecules of the gas as soon as the pressure is increased and temperature is decreased. That is at high pressure and high pressure and low temperature. So this is another point of difference between ideal gases and real gases. Now we can go to another point of difference between the ideal gases and the real gases. As far as our ideal gases are concerned, they obey gas equation. An ideal gas obeys which equation? Gas equation. What is gas equation? PV is equal to nRT. That is PV is equal to nRT. While as far as our real gases are concerned, they don't obey this equation. They don't obey the gas equation. Instead, they obey van der Waals equation. A real gas does not obey the gas equation. It obeys van der Waals equation instead. Van der Waals equation instead. That means instead of gas equation, real gases obey which equation? The van der Waals equation. What is van der Waals equation? Van der Waals equation is this: P plus AN square upon V square multiplied by V minus NB equal to pi RT. This equation is known as van der Waals equation. So these gases obey this equation. This equation is known as van der Waals equation. Now let us come to these terms in the van der Waals equation. As far as P is concerned, here P is pressure of the gas. Then we have V. V is volume of the gas. We have T also. This is temperature of the gas at which gas is kept. Then we have R. R is a constant known as gas constant. Then we have N. N means number of moles. Then we have A here. A. What is A? It is basically a constant. It is a constant which relates. A is a constant which relates magnitude. What is A? A is a constant which relates magnitude of attractive forces. Because according to van der Waals equation, there are attractive forces between the molecules of the gas. Then we have another constant in this equation, that is B, known as constant B. This relates to effective volume of gas. This is effective volume. Effective volume of, because according to van der Waals equation, there are the gas molecules do have volume. Their volume is not negligible as in case of these ideal gases. So this is the van der Waals equation. So real gases obey van der Waals equation. Now coming to one more difference between ideal gases and real gases, and the difference is the compressibility factor. In case of ideal gases, the compressibility factor which is denoted by Z is always equal to 1. Please remember that in case of ideal gases, the compressibility factor Z must be equal to 1, that is unity. So when Z is equal to unity, then the gas is known as ideal. But as far as our real gases are concerned, in this case, the compressibility factor Z is either greater than 1 or less than 1 and never equal to 1. Z is never equal to 1. Either it is greater than 1 or less than 1. So these are some points of difference between the real gases and the ideal gases. Again, I will tell you that we do not have these gases, that is ideal gases, because such a situation cannot be attained, and therefore we have real gases. Real gases are also known as imperfect gases. So this is all for today. Thank you very much.